These applets are astronomy simulations from the Astronomy Education Department at the University of Nebraska-Lincoln. So I'm going to start out here with the celestial equatorial demonstrator, the celestial sphere. And this is our reference in space, our own equator, and then the other two are the North Pole and the South Pole. Because the Earth's axis is tilted, and because we are standing on a round Earth, this is not how we can see the sky, but it serves as references to identify stars and their coordinates. So let me just click on a few things here so we can see North Pole and South Pole. There's our equator, and this here would be the celestial equator, which is right there. Oh, and then here's the North and South celestial poles. This is where Polaris is close to. Here, there's no relatively bright star that's close to it. And this one here is the ecliptic. This is where the sun's apparent motion occurs, respectively the planets as well. And I'm just going to go over here to the definition on Wikipedia. The ecliptic is the plane of the Earth's orbit around the sun. Since we think that we're standing still, we know better, we're not. From the perspective of an observer on Earth, it's the sun's movement around the celestial sphere over the course of the year traces out a path along the ecliptic. So, therefore, the sun goes around that. The ecliptic is an important reference plane for us because all the planets are also moving around the ecliptic. So when we find it, that imaginary line, then we also find the sun, the moon, and the planets. So going back to here, this was actually all on this particular diagram. All right, going over to this one here. So this is actually then our horizon here, and I'm going to put these in here. There's the zenith, so that's the point above. And then here's our horizon, right? And the meridian is really, this is where actually the stars would appear the highest in the sky. So we have east over here. I think it actually says that, yeah, east over here, west over here. So stars are rising somewhere over here, setting somewhere over there, and then they go highest to the sky, the south, and that's where the meridian is. All right. This one here, so putting the two together. So here is our horizon system, and oh, it actually shows here. This is actually Lincoln. I'm gonna change this one here to the Kenai Peninsula. Now, you know what? I'm gonna reset this, and I do that in a little while. Okay, so let's see. Show labels. So we're standing here, and this is our point overhead. That's the zenith. Then this one here would be the celestial equator. Here's the north celestial pole. So this is our axis going through here. And yeah, and then from space, of course, again, this is the north celestial pole, south celestial here, and this is the equator. Let's see what else I can put in here. I don't know why it doesn't let me put the ecliptic in here. This one here, these stars down here are the stars that we cannot see from a particular location. They're always under the horizon, beneath the horizon. Show and rise section. So these are the stars that are rising and setting. And this one here is the circumpolar region. These are stars that are always above the horizon for us. And now I'm going to change to our latitude and longitude, especially latitude is the one that really changes it. And notice our circumpolar region here on the Kenai Peninsula is much larger. We see a lot more stars all the time. But notice this one here as well. There's also a lot more stars that we never see. All right, let's see. So here we have our equator. Again, I don't know why the ecliptic isn't on here. I'm going to click on star pattern. I liked Orion earlier. And then I'm going to hit start animation, and we'll see Orion. Why is it going the wrong direction? Oh, no, it is. I don't know what it just did a moment ago. That looked weird. It's going the right direction. So from our point of view, Orion would be moving left to right. Short star trails here, I guess. Okay, something is moving the other direction. We can show another one here. So the Big Dipper would be up there. So start animation. And yeah, the Big Dipper then would move across the sky at all times from our point of view. All right, that was actually longer than I thought, but that's all right.